Vaults and Slabs. Lesson 1. Vaults and Domes. Introduction. Vaults are curved, load-bearing structures traditionally built from stone or brick. They rely on compressive forces between the individual elements to maintain stability. However, their main drawback is that they often result in a tall, structural height that is difficult to use efficiently and requires a large amount of building material. Vault construction requires the use of a template, usually made of wood. It can be dismantled when the vault is completed, but even the construction and dismantling is labour and material intensive. Modern slabs completely replaced vaults from the end of the 19th century. For aesthetic reasons, you may still want to cover your space with a vault. In such cases, the vault is often made of reinforced concrete. Vault types. The vaults can be formed by extruding or rotating a shape, arch, or intersecting two vaults. Depending on their shape, vaults can be semicircular and pressed or raised. Depending also on the type and position of the support, they may be closed, semi-open, or open. The most common types of vaults made of stone or brick are barrel vault. The barrel vault is the three-dimensional form of the arch. It can be seen as an extrusion of the arch along its longitudinal axis. It is a surface warped in one direction, which only requires support on the sides parallel to the longitudinal axis. Thus, it is considered a semi-open vault. The arch can have a variety of heights and shapes, diverting from the semicircular line, creating different subtypes such as segmental, three-centered arches and so on. Groin vault or cross vault. The groin vault is created by intersecting two barrel vaults of identical structural dimensions and shapes by removing the solid material of the intersection and keeping the vaulting outside the area of the intersection. The line of intersection of the vaults will be the groin, and the frontal arch will be the curve of the original dome. It is considered an open vault, with only the lower points of the frontal arches requiring support in piers or columns. In a Roman groin vault, the line connecting the opposite frontal arches is horizontal, and the ridge of the vault is semi-ellipsoid. In a Romanesque groin vault, the line connecting the opposite frontal arches is a rising arch, and the ridge of the vault is semicircular. Domical vault. When two barrel vaults are intersected, you get a domical vault by keeping the solid material of the intersection and removing the vaults outside the intersection. This closed vault type requires masonry support around it. Trough vault. The trough vault is an extended version of the domical vault, with a rectangular rather than square plan. The resulting vault is also closed. Covered vault. The covered vault can be derived from the trough vault by cutting it at about half its height with a horizontal plane and making a flat or almost flat vault at the cut. Domes are surfaces of revolution. They are often hemispherical, but can be made in pressed or raised arched forms too. Their base is often circular, but many domes have also been built on an elliptical base. Pendentive vault. A pendentive vault is a hemispherical dome that is raised above a circle drawn around a square, and then the parts outside the sides of the square are cut off with vertical planes set on the sides of the square. The resulting frontal arches are also semicircular. The pendentive vault is open and supported by pillars or columns at the corners. Sail dome. The sail dome is also considered an open dome on all sides. It differs from the pendentive vault in that the vertical intersecting planes fall significantly inwards from the circle above which the dome is raised. The result is a segmental rather than semicircular frontal arch. Construction of a vault. The vault were built as a continuation of the walls using the rules of good bonding. Due to the geometry of the arched structure, the radial elements create wedge-shaped mortar joints. For arches with a greater radius of curvature, it may be necessary to carve the bricks into a wedge shape. We will demonstrate the process and concepts of the simplest type of vault, the barrel vault, using brick as a building material. 1. Starting from the baseline, starting line, you mason the impost where the vault should begin. 2. To allow the joining of the arch at an angle, the bricks need to be increasingly cantilevered. A brick support with a sloping starting plane is formed from a straight plane with quarter and half bats. This creates a sloped starting plane with carved elements, which is typically 1 brick wide. This is the impost width. 3. Above the impost, the masonry continues upwards with vertical planes, and from the spring line you can start the masonry of the vault on 2 sides. The part between the two is usually reinforced with masonry infill. 4. A template and supporting scaffolding must be prepared for the vault masonry, and the vault has to be made on its surface. 5. When starting, you proceed with the thickness of the whole brick, impost width, in the masonry, following the curvature of the template. 6. In the middle section, the vault can be narrowed to the thickness of half a brick. However, every 1 to 1.5 meters, there will be reinforcing arches, similar to reinforcing walls with pillars.